Hey all, again welcome to Genie YouTube channel, part 4 on machine learning types. So in the previous parts, we went through supervised learning model under which we saw classification algorithm type and then regressive algorithm type. And again, we went through semi-supervised learning type, where we came to know about how only a small portion of the data set will get labeled, and rest of the huge set of data either can't be labeled, or labeling rest of a huge part would cost time or high cost. And again, we went through unsupervised learning model, where we went through clustering, association rule mining, and we went through dimensionality reduction, auto recommenders, and anomaly detection. Now, we are going to talk about reinforcement learning. So, what is reinforcement learning? Basically, it's a feedback based machine learning model, or which take iterative approach. So, as the name suggests, the learning gets reinforced time to time based upon the exposure and experience of the AI agent involved. So experience gets accumulated, and the accumulated experience will update the neural network time to time. And this updated model will be used to create better and improvised experience. So this kind of learning, which is reinforcement learning, essentially gets applied in the real-time environments. So in this case, the components in this learning type, or the AI agent, it involves action from that AI agent, and then the state and environment, and reward or penalty for the action of the agent. So the agent, when it gets exposed to environment, it will take actions, and that action will get credited or discredited. So this data, this action of the agent will get collected state by state, meaning what this AI agent is doing in a particular point in time in a particular environment. So that is what the component of state is all about in reinforcement learning. So the AI agent here learns to which action to be performed by looking at the environment and at the results. Results here is either reward or penalty of the action. Reward could be +1 point to the AA agent, and penalty could be either 0 or -1 for the AA agent. So here, the primary goal of an AA agent in reinforcement learning is to perform actions by looking at the environment and get maximum positive rewards accumulated. So here, the AI agent learns automatically using feedbacks without any labeled data. So let's look at these reinforcement learning components one by one. And as I said, this learning type is commonly used in scenarios where an agent must make a sequence of decisions over time to achieve a certain goal or objective. So the key components here in this reinforcement learning are agent, environment, state, action, reward. Let's look at all of these components by definition. Okay. So the agent involved here is the entity that takes actions in a specific environment. Here, the AI agent's goal is typically to maximize the cumulative reward it receives over time for every action. Another component, environment. And when we say environment here in the purview of reinforcement learning, it essentially talks about the external situation or system with which the agent deals with or interacts with. It responds, the environment will respond to the actions taken by the agent and provides feedback for every action from the agent in the form of rewards or penalties. And then comes the state. It's nothing but representation of the current situation or configuration of the environment, or a situation or configuration of the environment in a particular point in time. That's what gets referred as state. So this component state provides information about the context in which the agent is making decisions and actions. Now comes the action part. So it's nothing but a set of probable or possible moves or decisions that an AI agent can take. So the actions here will influence the state of the environment, the behavior of the environment. And comes the reward function. So it's nothing but a numerical signal provided by the environment as a feedback for agents' every action. So, as I said, the goal of the AI agent is to learn a policy, devise a policy or a strategy, or set a critical path that will maximize the cumulative sum of rewards over time. So, let's touch upon Tesla. We are not going to deep dive as to how reinforcement learning works in Tesla, but if you look at the Tesla's autopilot and full self-driving feature, it uses machine language or a combination of deep learning algorithms and AI models extensively. And of course, there is no reliable data on Tesla's usage of their essentially because of their proprietary it's all about their proprietary algorithms and models. These details are not obviously won't be available due to competitive reasons. But however, if you look at Tesla, there's an input gathering aspect where this autopilot or the full selfing drive mode processes vast amount of data generated by Tesla's cameras, onboard radar, and ultrasonic sensors. So all these input grasping equipments will enable the autopilot, which can also be called as semi-autonomous driving capability, to recognize and to interpret the surrounding environment, including other vehicles, obstacles, pedestrians, traffic signals, and road markings. And next comes the input processing part, which is essentially being taken care by the computer system on board. So this onboard computer system in Tesla plays a very crucial role in Tesla's autonomous driving capabilities. If we have to talk in terms of algorithms behind the input processing, it's the CNN, right, the convolutional neural network, and other Supervised learning techniques involves the CNN, or in the recent days they're also talking about YOLO. You look YOLO. It's an abbreviation of point. You look only. I couldn't able to recollect the expansion behind this abbreviation YOLO, but it's an algorithm type of algorithm that are being presumably applied in Tesla for object detection, lane keeping, and to abide by traffic sign by recognizing the traffic signs. So, application of deep learning models are used in Tesla's control system, and thereby it augments steering, acceleration, or be it applying brakes on real-time environment conditions. And all these decisions and actions are taken in a micro fraction of a second out of huge set of real-time data processing. Obviously, for safety reasons, in road while you drive, even delay over a microfraction of second can create accidents and disasters. So here, the type of machine learning that gets applied, which is nothing but reinforcement learning, wherein algorithms are used to enhance Tesla's navigation systems and thereby providing accurate routing. And again, all these accurate routing directions comes from the historical data that was fed and then going through a systematic supervised learning approach so that the reinforcement algorithm can be prepped up for Tesla's real-time conditions. So there is a credit assignment system for every action being taken by the car during its learning time, right? So basically, this environment will be divided into grid, and each grid will be having some weightages. Say, for example, if a Tesla has to reach to a particular destination, if it takes a right step instead of a left step, it'll get a penalty, probably minus one or zero, probably a minus 1 point. Right now, each grid, as I said, were given weightages. If it takes a right turn, it'll get a plus one credit reward, or if it takes a wrong action gets minus one. So each of these weightages are given in the grids. If the car's actions lands up in the right grid, as I said, it would get a penalty. If the car's action, if the AA agents within the car ends up in a wrong grid by wrong action, it will get a less weightage or a negative weightage. So by the time car reaches the destination, it would have accumulated a reward, cumulative reward that will get evaluated, and that gets correlated to the car's actions, and that will go as a reinforced input to the learning model, and the outcome will get applied as an update, or we will see improvised experience or improvised sequence of actions from the car, wherein by the next attempt it would have accumulated a good level of reward points as against the previous times with low scores. Now, there are types of reinforcement learning. All these are distinct topics by themselves. One is a model based reinforcement learning, and another prominent reinforcement learning model is value based. That is something called policy based, and Tesla is prominently, this is the type of reinforcement learning, that is policy based reinforcement learning, gets applied in its through the computer, through its onboard computer computing system. And there's something called actor critic reinforcement learning, and then there is off policy and on policy types of reinforcement learning. We can go through all these subtypes of reinforcement learning one by one in our next video session. Thank you.